Hi everybody, I'm Giles Lavelle and welcome back to Python from Scratch, a video series for NetTuts. In this series we're learning Python from the ground up. We're going from never having used Python to having enough experience with it to use it for web development. In the first episode we got set up, so we downloaded and installed Python, chose a place to write our code, and then finished off by writing a Hello World script. Right, so today we're moving on to start some actual programming, and hopefully by the end of this lesson you'll have a solid understanding of the basics of Python and everything you need to progress to further levels. So what are we covering in this episode? Well, we're going to learn about several concepts, including variables and the data types that they can contain, and then we're going to move on to manipulating those variables with different operators, and then finally finishing with some control structures like conditionals and loops. A lot of this tutorial is just lots of single lines of code that we're going to be testing out and learning the concepts behind. So the Python shell is much more appropriate for this tutorial than writing a Python script in a text editor and then running that like we did last episode. So open up the Python shell and you'll be ready to start. Remember, if you're on Windows, then you have to go to your Python directory and run the Python shell executable. It's just called python.exe, and it'll be wherever you install Python when you run the installer. If you're going to be doing a lot of Python, I recommend making a shortcut to it so you can get to that more easily. If you're on a Unix system or Unix-like system, so Mac like me, or on Linux, then you can get at Python right from the terminal. So that's what I'm going to do right now. Open up terminal and then type Python. And we are now in a shell where all our Python code can be evaluated. And once you've got to this point, you are ready to start the tutorial. One thing that you should notice before we start is that it says 2.7.1 here. If you're on a Mac and you've got Python pre-installed, that'll be 2.6.1. So make sure you've gone through the first tutorial and upgraded to the latest version of Python from the website. So that we're all using the exact same version, and therefore all the code will run exactly the same and you won't have any frustrations or problems where you're doing the exact same thing and not getting the same answer. If you chose to use Python 3.1 in the last episode, that's fine and most of this will run, but be prepared to probably have a few little differences. Right, so now we are ready to start covering some of the concepts of this lesson. And the very first one we're going to do is variables, because variables are the most fundamental concept behind programming, completely essential, and it's definitely the first thing you should learn. So, well, what is a variable? You can think of a variable as a place to store some data, and you can give that place a name so that it's easy to know what the data contains. So the way you write it in Python is really simple, traditional for Python. It keeps it much more simple than other programming languages. And the way you do it is name equals value. And name can be anything you want, and that name should describe whatever value is. So in other programming languages, you might have seen a few things. In PHP, you have to put a dollar, so it would be $name equals value. If you are in JavaScript, that would be var name equals value. And some of the more low-level languages, for example C#, you would have to specify the type. So that would be string name equals value or int name equals value. But Python, we don't need to worry about any of that. You can see how much simpler it keeps it. We just have name equals value. So what can these values be? Well, the value can be any kind of data, and we sort the data by data types. Now there are 4 ones that I think are the most important to learn for the day, and they are numbers, strings, lists, and booleans. And they're all handled slightly differently. So first let's create a variable and store a number in it. So let's create one called 12. Give it the value 12. And now 12, the variable name, holds the number. This is kind of pointless in practice, but it's just to give you an example here. And this means if we were to type 12, it would evaluate as 12. But now we've put that exact same value in the variable name 12. That works exactly the same way. So we can type 12 again, and it evaluates the same because it contains that value. And you can see here the fundamental concept behind variables. You take some data and put it somewhere else and give it a name. So that's a number variable, and there are two types of number variable that are really important. There's integers and floating point numbers. And floating point numbers are what you might commonly think of as decimals, and they're not a whole number basically. So you could have you could create a variable just called a, and you could give it a value of 10, and then create a variable called b and give it a value of 10.5. And a would then be an integer and b would be a floating point number. But you don't need to worry too much about that, because Python handles all of that for you. And you can see you don't have to do any declaration. You just type the variable and Python will work out what type it is from what it's like. So that's numbers. Let's move on to strings now. And strings are just any number of any character at all, and they are treated as regular text. So with numbers you can add them up, take them away, but with strings you can stick strings together or remove particular letters or find out how many letters are in the string. So you can do different things with them. So in our last example we did a hello world program, so you could make a variable called greeting and you could set it to equal hello world. Right, there we go. You can see we've actually got an error there, and what I've done wrong is I have used a single quote at the beginning and a double quote at the end. And you can use either of them, but it has to be the same one at the beginning and the end. So let's give that another go. Greeting equals hello world. And that's worked now, and if I type greeting, I get that value. But I could also do that with single quotes. You can use single or double quotes, it doesn't matter, but you just need to be aware that it has to be the same at the beginning and end. Now this presents us with a problem, because what if you then wanted to use a single quote or a double quote within your string? Remember that the quotes here are exactly the same as apostrophes. So if we wanted to have the string can't, then that would be like we were starting another string there, but we're not. So you have to do a thing here called escaping, and that's just where you put a backslash right before a single or double quote, and that means it just gets evaluated as the character it actually is and not something to wrap a string around. So if we do that, it gets evaluated there as an actual apostrophe, not a quote. And that's one of the most frustrating things at the very beginning of learning programming languages, trying to escape characters. So that's an important thing to learn at the very beginning. So now we know about numbers and strings, let's think of our third data type, booleans. Booleans represent a true or false value. So that can be thought of as a 1 or a 0, a yes or a no. But in Python you say true or false, and it's used to represent the state of something. It can only be on or off. In most languages you put it as lowercase, so it would be true. But in Python, the first letter is capital, so we have true and false. And we can use this to represent something which can only be one of two things. So for example, if we had a program which had to manipulate some customers and it had a database with their genders, we could have a variable called, sorry I didn't mean to hit enter there, variable called is male, and we could set that to true. Now that could only be true or false. A person could only be male or not. The final data type we're going to look at is lists. And if you've come from any other programming languages, you might have heard of them as arrays. They're called arrays in almost every other language, but in Python they're called lists. And what they are is they are ways of grouping together lots of other variables into a whole group data structure that contains them all. And it gives them all a number within that data structure so you can access them. the easiest way to demonstrate it is just to assign it. So we could say my list equals 1, 2, 3. And you can see the syntax there. You assign it like a normal variable with the equals, but then you put square brackets. And this denotes that you are making a list. And within that list, you can put as many things as you want, but they are each separated by commas. If we then evaluate my list, you can see it contains those 3 values. Lists can contain multiple data types themselves, so we could have, if we reassign my list, we could make it contain 1, hello, and false. And you can see there it contains a number, an integer, a string, and then a boolean. And so then it can contain multiple data types. It can also even contain other lists. So my list could contain 1, then a list of 1, 2, 3, and then finally true. And you can keep nesting lists as much as you want, so you can create really efficient data structures which organize your data into grids using lists and lists within those. A really useful trick in Python is multiple assignment, and that can make your code a lot cleaner. So you can assign multiple variables on the same line. So say we wanted to create 3 variables containing 1, 2, and 3. We could say A equals 1, B equals 2, C equals 3. And that's fine, but if they're getting really big and they're all similar like this, then you can group them together in one line and it makes it much easier. So we can just say A, B, C equals 1, 2, 3. And that's done exactly the same job, but in one line. And notice you just separate them by commas and they match up. So the first variable name gets the first value, second variable gets the second value, and you can do as many as you want on one line. If the variables don't have anything to do with each other, then this isn't a great idea because it implies some sort of connection. But if you're assigning lots of variables that all work towards some common purpose, then it's sometimes cleaner and simpler to assign them like this. You can also give multiple variables the same value. So you can say A equals B equals C equals 1. And now A, B, and C have all gained the value of 1. So we can see that A equals 1, B equals 1, and C equals 1. And now let's try overriding it with what we learnt earlier. A, B, C equals 1, 2, 3. And then A, 1, B, 2, C, 3. So that's 2 different ways of multiple assignment of variables. And this is an important thing to notice. Variables in their name can vary. B had the value of 1 and later it had the value of 2. So variables are places to store data, but they only last until you change them, and then after that they have a completely different value. So it's important to think about that when you're using the same variable in lots of different places, because it might not have the value you expect. So this is where it's important to be very careful about the logic you use in your programming. But we'll cover that in more detail in the subsequent lesson. A final thing to notice about variables is that you must define them before you can use them. In other languages you might be able to say, for example in JavaScript, you could just say var a, hit enter, and then a would be a variable but it would have nothing in it. And you could call a and it would just tell you it wasn't defined. If we try and do that in Python, just create a variable but not assign it, so we could create new variable, it would try and use that variable and tell us it wasn't defined. So you have to give them a value. But that's okay, because you can give them a base value which doesn't really contain any meaningful information, and then when you need them you can then add the information. So if it was a number, this base value could be number equals 0. If it was a boolean, we could have the boolean as false, and if it was a string, it could just be an empty string, so just 2 double quotes with nothing in the middle. So these are all very base variables, don't really have any information, but it means that you can then use them. You type string, and it will give you string, which doesn't contain anything, but it does exist in the current document. And that's quite important, because sometimes it's good to create all your variables at the beginning, give them all just base values, and then start doing things with them later, because it makes the logic a lot cleaner if they're all coming from one place. So you now know quite a bit about variables, and another thing that we can cover is comments. Now, comments are very important. It's a really good practice to comment your code, because comments are lines that don't get executed. Python just completely ignores them, pretends they aren't there. But when they're in your code, you can read them, and you can use them to leave little reminders to yourself about what the code does. This is useful in two situations. It's useful if you come back to it in 6 months and wonder what the hell is going on. And it's useful if someone else decides to work on the same project as you, so then they can see what you've done. In Python, you use the hash symbol to assign a comment, and then type anything you want. It doesn't have to be, it's just any English or whatever language you speak after the comment. So this is a comment. And you can see in the interpreter, it's then let us go on to evaluate some other line. So we can then just type, call a variable like a. But now we have a comment, and we can make that reflect something. So we could say a has the value 1, and then that would remind us that when we used a, it would have the value 1, and we type a and there it is. It's important to notice that there's no point in doing this, because if you've got a equals 1 in your program, to anyone who understands even the most basic amount of Python, it's going to be obvious what that is. And if you try and comment every single thing you do, your code's going to get really full and messy of all these comments, which are just, they don't add anything to the information. Also, if you then change and say a equals 2, but don't change the comment, then the comment will be wrong and completely misleading. So don't comment things that are completely obvious. There's no rule of thumb, but you've just got to use your best judgment. And make sure that you comment when you need it and not when you don't. If you're absolutely sure you're only going to be working on it for the next week and then never again, and no one else is ever going to work on this project, then you probably don't need to bother. But it's a good idea if you are working on a project that's expecting to have any sort of longevity. It's important to note that the hash symbol doesn't always create a comment. For example, a hash symbol in a string surrounded by quotes would not be a comment. So if we said not a comment equals hi there, if we then called not a comment, it would evaluate, and the hash is then just another character, because remember, strings can contain any characters, so letters, numbers, or symbols, and the hash is not a comment there. So you can put comments on the same line as code. So we could put is alive equals true, for example, if we're making a game and we had a character, and then we could say sets the character to being alive, and then the comment is on the exact same line. If we then call is alive, we can see that's evaluated like a regular variable, but we know a bit about it from the comment. And that's another example of where you wouldn't really need a comment, because you can see exactly what that does. But if you're doing something really complicated, then you could easily put a comment there. So now we've learned about a lot of stuff: variables, data types, and comments, and that is a really good grounding in Python, and we're making a lot of progress. But before we finish this lesson, we've still got to cover operators and control structures. So there's still quite a bit to do. So let's move on and learn about operators. Operators is a technical term, but you don't really need to worry about them too much, because if you've ever done any maths at all, then you'll know exactly what an operator is. Operators are things like plus, minus, multiply, and divide, and they work in Python just like they do in regular maths, not in programming languages. So for example, we can do 1 plus 2, and we get 3. And you can see there that the plus operator has added those two numbers together. The two numbers that are being operated on are called the operands, and the plus symbol is called the operator. But you don't need to worry about that. You need to know that when you're talking about numbers, plus adds them together. Earlier we created some variables which contain numbers, so we had a was 1 and b was 2. So if we do a plus b, we get 3, just like we've done 1 plus 2, because that's the value that those variables contain. So let's just run through a few more examples. 4 plus 5 would then equal 9. If we did 2 times 6, we would get 12. If we did 12 divided by 3, we would get 4. And if we did 8 minus 3, we would get 5. So you can see it's just like regular maths there. A few more things to notice. If you've got a floating point number with a decimal point and an integer, when you can do anything you want on them, add, multiply, divide, whatever, and the integer will get automatically converted into a float. You don't have to worry about that. So if we did 5 plus 1.2, it would then convert that and the answer would be a float. So you don't have to worry about losing the decimal point. And if we did 7 divided by 3, that would not return a whole number. But you notice there it does return a whole number, and that's because when you do division, it rounds it down. So we get 2 point something and then it rounds it down to 2. The last two operators we're going to learn about here are the modulo and the operator to raise numbers to a power. So modulo is similar to division, but instead of returning the number, it returns the remainder. So in our example there, 7 divided by 3, we got 2, but that gives us a remainder of 1. So if we did 7 modulo 2, we would get 1, because 1 is the remainder. If there is no remainder, then the result is 0. So 10 modulo 2, that'll give us 5 with no remainder, and we get 0. So the modulo operator is the percent symbol. The power symbol is just like the multiplication symbol, but there is 2 of it. So if we did 2 to the power 2, that's just like doing 2 squared, and we get 4, which is 2 squared. Then we can do 3 to the power 2, and we get 9, so 3 squared. And you can raise it to any power you want, so we can do 3 to the power 4, and we get 81. 3 to the power 3, we get 27, which is 3 cubed. So those are the 6 operators that you're probably going to end up using the most, and they are the most essential. Operators don't only work on numbers though, they also work on strings, but there they have a different meaning. So if we were to create a variable, let's call it j equals hello, and k equals world. If we then did j plus k, it would stick them together, and this is called concatenation. It's a bit of a long word, but all it means is that you're taking the first one and the second one and sticking them together into one whole string. So you can use these operators on strings as well as numbers, but they do different things. So let's hit enter there, and you can see it's combined it to one string containing hello world. We can also assign the result of that to another variable and then call that. So if we did L equals j plus k and then called L, it would contain the value of j plus k. Now in Python, if there are 2 of these strings right next to each other with nothing in the middle, it will actually do this automatically for you. So we can do hello as its own string, and then world. Sorry, I didn't put the extra quote in there. And you can see there, that is all in one string. There's a quote there, but the middle bit, all the same. But it's important to note that this doesn't work with variables. So we couldn't just do jk. That wouldn't work. You have to have the actual strings together. You can also use the multiplication operator on strings, and here it works as a repeater. So if we did hello times 2, we get hello hello. And then you can use these all together. So you can do hello times 2 plus end, for example. And then that will repeat hello and then add the final string to the end of it. And you can keep stacking these up using these operators together. And obviously that will work in the maths operators as well. So 4 divided by 2 plus 6. And then we will get 2, and then it'll add 6 to it, and we'll get 8. So you can put as many as you want on one line. You can also use brackets like you would in regular maths if you wanted to separate them in a certain way. So you could do three plus 4 over 2 would give you 7 over 2, but it would round that down. But then remember, that's going to be different to what you get if you regularly did 3 plus 4 over 2, because it's important to notice that the division and multiplication operators get run before the addition and subtraction operators. So if you want your addition and subtraction to be done first, you have to do that in brackets, because brackets are run before anything else. So what this is doing here is it's doing 4 over 2, getting 2, adding 3 to it and giving us 5, which is very different to what we're doing here, is we're creating 7 and then halving it. That's a pretty solid understanding you have now in operators, and I think we're ready to move on to the final part of this lesson, which is the control structures. If that's all been quite overwhelming so far, then just keep going back and watching this video and practicing through it, because it doesn't take very long to pick up, even though there are a few different ones to remember. So finally, let's learn about some control structures. The two most basic kind of control structures are called conditionals and loops, and they are the two we're going to be covering today. We can cover more of them later, but for today we're going to get a solid understanding of the basics that we need. A conditional is where in your code you want to decide between one thing or the other, or even multiple things. So using our example from earlier, if we still have our isAlive variable, then that still contains true, and then you can use that to make decisions. This is the kind of code that works better on multiple lines, so I'm now going to go to a text editor and we can write some code. You can use the IDE, text editor, idle, whatever you chose in the first episode to do this. It all works the same. So for conditionals, you write if. If has the exact meaning it regularly does. It does something if something is true, and something else if it's not. And in Python it's very simple. You just put if, then what you want to check. So here we can put if isAlive. Then you put a colon to emphasize that you are starting a code block. And then remember to indent to show that it's all part of that block. And then we can just print congrats. There we go. That'll do. And then exit out of the code block. Right, so let's save that out, and we'll call it just call it lesson 2 for now. Make sure to save it as Python code so we get the syntax highlighting. This will be different for whatever you're using. If you're using an IDE, then you can probably just hit run. Where's Python? Where are we looking at? There we go. Save that. Right, so let's go and then run that code. I will create a new tab, navigate to my documents directory, and then run Python on the lesson 2 file. Right, so we've got a problem there, and as we can tell, obviously isAlive doesn't have any value because we've created a brand new document. So let's give isAlive a value and say isAlive equals true. Go back to the terminal and run that again. And now you can see it's printed out the line congrats because isAlive is true. It's checked if is alive, and then run through it. If we set that to false, we would then expect nothing to happen, because it would do if is alive, and it wouldn't be true, so it would just skip right past it. So let's go back to the terminal. Sorry, save that out. Back to the terminal, run that again, and we get no output because that hasn't happened. And you can do many things here. You can run all sorts of different checks. So you can do whether a number is less than another number. So you can do if 2 is less than 3, print congratulations. And that'll obviously print because 2 is less than 3. So we'll save that out, bring up the terminal and run that again. So you can see that's worked. We could do if 2 is greater than 3, and then we would then expect that not to work. There we go, we get nothing there. You can also check if something is equal. So we could do if 2 equals 2. Now you might be expecting to do that, but remember that is how we assign variables. Up here we're using equals to assign. So that doesn't work. So what we do is we use double equals. And that works just like you'd normally expect equals to if you were doing some maths, but you have to have a different way of writing it so that Python doesn't get them confused. So if 2 equals 2, save that out, then we get congratulations, because obviously 2 does equal 2. But if 2 equals 3, save that out, we'll expect to see nothing. And there we go, we see nothing. So you can do all sorts of checks. There are a couple more I want to cover. You can also do not equals, and that uses the exclamation mark and then an equals. So that means if 2 does not equal 3, then we'll print congratulations. And that is what we would expect to see. So yeah, there we go. But if 2 does not equal 2, well, 2 does equal 2, so that's not going to work. Sorry. Then we would see nothing. You can also check if something is less than or equal to something. So if we had, if 2 is less than or equal to 3, and it is less than, so that'll work, save that out. Try running it, and there we go, it's less than, so it runs. But then if we could also put if 3 is less than or equal to 3, well, that'll work because it is equal to it. So that's one of the conditions that works. So then we run that, and it'll work again. And then the same works for greater than or equal. So we've got the greater than symbol there. And that works in the exact same way. You don't just have to check numbers here. You can check pretty much anything. You can go if is alive equals false, and that'll work. But remember, when it's a true or a false value, you don't need to check the equals. That works. You can do just if is alive. If it's true, it'll go through. If it's false, it won't. So that's a good way of speeding things up. But it's important to note that you can check booleans, you can check strings, you can check numbers here. So for example, we could do if a string containing the letter A was equal to a string containing the letter A. Save that out. And then there we go, we would get our success message because those two strings are exactly equal. So you can check any data type there. Another important part of the conditional concept is the else statement. So in Python, that is just else, and then a colon, and then indent to show you're in your next code block. And then you can do what happens if that is not true. So you can have the alternative thing that you want it to do. So we could have that print, sorry about that, if it's not alive. So let's do if is alive. Save that out. And there we go. It's skipped past the first one because it is not true, and it's run through the second block of code, and that's what we'd expect to happen. You can also check through multiple things by using the else if thing, which in Python, keeping it short, is elif. So that means we can have 3 options. But here, this wouldn't really have any meaning because is alive only can be one or the other. So let's create a variable. Let's just set a to equal 3. And then we can say if a is greater than 3, print congrats. Else if a equals 3, print blah. And then if it's not greater than and it's not equal than, then we just print sorry about that. Obviously this doesn't really have much of a meaning, but it's perfectly good as an example. So we just run through that, and there we go. A is equal to 3, and we get blah. If we set that to 17, it would be greater than 3, and we'd expect the first code path. We can see there we're getting the first code path. So you can see just how easy and simple these conditionals are. Just allows you to check through any variable or any value and do something as a response. And you can have as many lines as you want here. So you could keep writing more and more code, but as long as it was all indented, that would all still work. The very final thing I'm going to cover in conditionals before we move on to loops and then finish the tutorial is the concept of checking multiple things at once. And we're going to cover the and the or operator here. So we can say here that we check 2 values. So let's have A is 17 and B is 18. And then we can say if A equals 17 and B is equal to 18, we would then expect that to print congrats. So let's give that a go. And there we go, we get the congrats message. So you can see just how readable Python is. In some other languages you use the ampersand symbol, but in Python it's just the word and. There's another one which is or, so we can do or, and that will go through if any one of them is, so it doesn't have to be both. And means unless both of them are true, it won't go through. Whereas with or, it can be one, it can be other, it can be both, it doesn't matter. As long as at least one of them is true, then it will run through. So we could change the value of 18 to 24. That would mean only one of them was true, but that would still be enough for this one to run. So then we do that, and we still get the congrats message. If we then change that to 15, then neither of them would be true, and then it wouldn't run through. And then we would get the sorry about that message. Final one I'm going to mention is in. So we can do if A in happy, and then check that. And as we can see, A is in happy. There's an A right there. So we can then run that, and we get the congrats message because it's checked if that's in that. We can also use that for the lists we learnt about earlier. So if we made a list that contained and then if we go if 1 in my list, and there we go, we get congrats. So you can use in to check if letters are in strings or if a value is in a list. So multiple uses of in there. Before we actually move on to the final order of the day, which is loops, I am just going to cover something that I almost forgot about, which is slices of strings and indexes of arrays. So before we saw that we made, if we go back to our Python tab, we saw that my list had all of these values. And if we wanted to access an individual one of those, we use an array index, and that uses the square brackets again, but we use it after the name. So we type mylist, which is the name of our list, and then the index we want. So that would be the number of the position of it. So that's the first thing, that's the second thing, and that's the third thing. But if we type mylist1, you'd expect us to give us 1 then, because it's the first thing. But it gives us the second thing. So what's going on there? Well, like in most programming languages, Python indexes things from 0. So the first thing has an index of 0, the second thing has an index of 1, and it's all quite a weird way of thinking about it, but it makes sense once you get used to programming. So if we do mylist 0, we get the very first thing. As you can see here, we've got a list within a list, and you can access them probably quite logically with two arrays next to each other, two indexes next to each other. So we can do mylist1, which will access that list that's nested within it, and then we can get the final value. So that'll be 0, 1, 2. So if we want to get that 3 out, we do mylist1, 2. And there we go, we get the value 3. So you can use these array indexes to access all the different parts of your array. If we did mylist2, we would get the true value that's stored in the 2 index. And you can also use these on strings. So if we had a string that was happy and then we did 2, we would count 1, 2, 3. It would probably print P. And there we go, we've got the P. So you can use these slices to access individual parts of strings. You can also do a few other slightly more complicated things with them. If this goes over your head, then don't worry about it, but it's worth mentioning. You can put a colon in the middle of your indexes and select a range. So if we did hello and then selected 2, we would get the L. But if we did hello and then selected 2 to 4, we would get everything between 2 and 4, which would be everything between L and O. So we would get L and L. But the important thing to notice is it selects between, so we don't get the O. It's everything from the first one, including L, up to before the last one. So we get L and L, but not O, because O is the last one, and it's before the last one. So if we wanted the O, we would do the same thing, but with 5. And then we would finally get the O. And you can use these in multiple combinations to select any part of a string you want. So we could also do omit the first one and just have a colon and then 4, and it would select everything up to 4. We wouldn't have to put 0 in. It would do that automatically, so it goes up to hell, which would be exactly the same as doing hello 0, 4, but because it's the first one, we can omit that. And the same if we wanted to start from a point and go all the way to the end, we can just do hello 2. And there we go, that's the same as 2 but without the colon. The final thing about these slices is that you can actually use negative numbers, and that counts from the other side. So if we did hello negative 2, it would count back from the other side. So we go -1, -2, and it counts back. Let's try that again with 4. We get the E, so it goes 1, 2, 3, 4. So that first one is always 0. If you count to the right, you get 1 there. If you count to the left, you get 1 there. And that lets you select things. If you've got a massive long list of numbers or a really long sentence, you can select from the back, because it's sometimes much easier to count from the back than it is from the front. Right, so let's finish off and learn about some loops. Get rid of all of these things that all this stuff that we don't need, and make our first loop. There are two kinds of loops we're going to learn about today, the most basic ones. First one is for loops, and the second one is while loops. Now the for loop keeps running for each item in a list. So the name is quite descriptive there. So we could do for A in my list. And then what we would have here is A taking the value of every one of my list in turn. So A would take the value of 1, then we would do something. Then A would take the value of 2, we would do something. and finally A would take the value of 3 and we would do something, and then it would stop. So it would run for each value of my list. So what we do here is we indent like all code blocks in Python, and what we could do is we can print A, and then we would just get the numbers 1, 2 and 3 printed all on separate lines. So let's try that. Let's run our script again, and then there we go. It's run through the list and done 1, 2, 3. We could also try something like print A plus 3, and that would gain the value of 1, 2 and 3 each time. So we would get 4, 5 and 6 as it added them to 3. So save that out, run it another time, and there you see 4, 5 and 6. So what we have here is the for loop iterating through every value of the list. If you want a predefined set of values and you don't want to create it before, you can use this thing called the range function. Now I won't tell you anything about how it works at the moment because we're going to learn all about functions in the next lesson, but all you need to know is that if you type range and then in brackets put a number, it will loop through every value between 0 and 1 less than that number. So if we did for A in range 10, print A, save that out and run it, we would get all the numbers between 0 and that number. And there's a lot more you can do with range, and we won't cover that today, but you can see that it's very useful for these for loops, because what it does is it lets you create this one line without assigning any previous variables, and it lets you loop through. You can also loop through lists which contain things other than numbers, so we could have 1, hello, false, and then if we do for A in my list, run that, then it prints all of those out. So that's the basic principle behind a for loop. Now we should cover the while loop. And while for loops deal with lists, while loops deal with conditions, just like the conditions we were seeing in our previous thing with the if statements. So where we would do if A is less than B, A is less than B, here we could do while A is less than B, and then run some code. Now that would keep running for the entire time that the value of A was less than B. And if we never changed the value of A, that would run forever, and that's a very bad thing to do because it means that the code will probably crash. So what we should have in this loop is some code that actually increases the value of A. So we can have while A is less than B, print A, and then increase A by the value of 1. So we could do A equals A plus 1, and then that would increase it. However, there is actually a shorthand way of doing it, and this is plus equals 1, and that will add 1 to the value of A, and it's just the same as what I just wrote, but it's a more concise, and you can actually do this with any of the operators. So you can do divided equals 1, and that's the same as A equals A divided by 1. So you can use the those extra operators for a more concise code, but here we're going to do A plus equals 1. So A will gain the value of 1 each time, and then when it reaches 23, when it reaches 24, it will be equal, and this will no longer be true, so this loop will stop running. So if we go and execute that, you can see it's increased each time, printed the output, and it's reached 23. A has no longer been equal to, no longer been less than B, so the loop has stopped running. But it's important with while loops that you always have them contain some code that will mean they stop eventually, because you can just put while true and that will never become not true, so that's a very bad thing to do. You should always make while contain conditions that are eventually stopped. With loops you can always also nest them, so we could have something like for A in range 3, and then indented in that for B in range 4, print A multiplied by B. And this would give us a nice multiplication table, because we would have all the values of 0, 1, 2, and for each time we had those, we would have all the values 0, 1, 2, 3. And it would go through each combination of those and multiply them all together. So this is going to give us quite a lot of output. But if we go and run through that, okay, you can see we have an error there. And of course we need the colon at the end of the loop statement. So have another go at that. And there you can see it's multiplied them all together. So 0 times 0, 0 times anything is always 0, so that's run a few times, and then it started multiplying the numbers. And eventually we get up to 2 times 3, which is 6. And remember, range runs up to 1 less than the number, so that's why we haven't got 12 as the very last one. So remember that you can nest loops, but if it's a for loop, you can't have the same thing, because you can't have for A in range 4, for B in range, for A in range 3, and then for A in range 4. It has to be a different variable each time, because otherwise then A is going to get overwritten each time we go in, and it's just going to multiply the number by itself. So that's no good. You've got to make sure that if you're nesting loops, you've got to have different variables for each indentation. And it's important not to nest loops too many times, because otherwise they can run forever and ever. So if you had for A in range 1,000, for B in range 1,000, that would already be making 1,000,000 combinations, and they can get exponentially hard for the computer to process the more loops you nest. So you've got to make sure that you use them with caution. Right, so then this has been a bit of a mammoth tutorial, but we have covered a whole load of ground, and if you've followed everything up to now, then you're pretty proficient with Python, and you have a really good understanding of all of the fundamental concepts that you need to take it to the next lesson. So next time we're going to be covering libraries, so they're other people's code and how you import them. We're going to be covering functions like the range one we've seen here, and we're going to be looking into what they are in much more detail, and also creating your own functions, not just using Python's ones. We're also going to do a bit of a talk about how it's different from other languages, because there's a lot of ways in that Python is different to other languages, and that's part of what makes it so great. So we're going to learn about that and how you can use that to your advantage in the next tutorial. So I really hope this has been useful to you, and you've taken a lot away from today's lesson. There has been a lot of content, so just feel free to just watch it again and again and keep going back through it and getting better each time if you haven't taken it all in one go. And I hope you will join me for the rest of the series, when we will get even better with Python. So thanks so much for watching. I'm Giles Lavelle, and this was a video tutorial for NetTuts. Goodbye.